In question number 35, we have a function y that depends on two variables. It depends on t as well as on x. So at one time when we are finding the derivative, we can consider only one variable, one of the components to be variable, the other would be treated as a constant. So the question is asking us to find the derivative of y with respect to x first, and then derivative of y with respect to t later. So when I'm going to find the derivative of y with respect to x, we are assuming that the change in y is happening only because of x. So I'm changing x and the values of y are changing. So in that case, t will no longer will be considered as a variable, it will be treated as a constant. We say that t got no contribution in changing the values of y at this moment. So wherever there is t, I will treat t as a constant. I will keep it out of the discussion. I will just take the derivative of x square because the function is being differentiated with respect to x. Plus t cube will be treated as a constant, it will be kept out. Derivative of x only will be taken. The derivative of x square will be 2x, the derivative of x will be 1. We simplify it and get the answer. While we are taking the derivative of y with respect to t, that means t is the contributing factor. It's contributing to the change of y values. So y values are changing because of the t. So that in that case, x will be treated as a constant. So wherever you have x square, you will keep it out. Just take derivative of t with respect to t. Plus where you have x, you keep it out, take derivative of t cube. Now remember, if you take derivative of x with respect to t, where x is being treated as a constant, this will become 0. Okay, so that's why we are not finding the derivative of the other parts or something. So the derivative of t is 1, the derivative of t cube is 3t square. Now we have x square plus 3t square x, and Salar is knocking on the door. In question number 37 to 40, they give you a point and a curve and ask you to find the equation of a tangent line on the curve at that specific point. So we take question number 38 because it has e power x. I thought it would be new for you. So y equals to 2 e power x plus x. We need to find the equation of the tangent line at this curve at location 0, 2. Now when we are given a location, it has x and y coordinates, so the first value will be taken as x1, you take it x0 or x1 or x2, whatever name you give to it. The second value will be considered as y1. Okay, we know that the equation of a line, if we have a point and slope, the equation of line will be given as y minus y1 equals to slope times x minus x1. We keep y and x the same because they will show the relation of x and y in the line, that they would make a line. We need to put the values of y1 and x1 from this point. So we have x1 to be 0, we put it there. We have y1 to be 2, we put it there. So the only thing that is remaining is m, the slope of the tangent line. By the idea of derivative, we know that the slope of tangent line means the derivative of the function. So we take the derivative of the function for finding the slope, and it will be a general slope. So it will be the slope for the entire curve, but we need slope at a specific point, at this point. So we will put x equal to 0 in that slope. We find the derivative, we keep 2 out, take the derivative of e power x with respect to x, plus take the derivative of x. The derivative of x is 1, 2 is being left out, the derivative of e power x is e power x. Now we got the derivative, we put x equal to 0 in it. So 2 e power 0 plus 1, e power 0 is 1, 2 times 1 is 2 plus 1 3. So I got slope equal to 3. We put m equals to 3 here. So we have y minus 2 equals to 3 times x. This negative 2 will get added on the other side. So y equals to 3x plus 2 is the equation of the tangent line to the curve at location 0, 2. In question 49, we need to find the higher derivative of a function f of x equals to 0.001 x power 5 minus 0.02 x power 3. We find its first derivative. They've asked us to find the first and second derivative. So we find the first derivative. So we find the first derivative. We keep 0.001 a constant multiple out. We take derivative of x power 5. We keep negative 0.02 as a constant multiple out and take the derivative of x power 3. Now the derivative of x power 5 is 5x power 4. We multiply this 5 with the constant that we have outside. We get 0.005 x power 4 minus this 3 gets multiplied with the constant and we get 0.06 x power 2. That's the first derivative. In a very similar fashion, we will find the second derivative. So for the second derivative, we will keep this constant out, take derivative of x power 4, and similar way keep the constant out, take the derivative of x square, simplify, and we get our results. In question number 53, you have to use the same idea of finding the first derivative, but only the numbers are in fraction, the constant multiples are in decimal form. So I thought it might be confusing for you. Just use the same idea and you will be good to go. In question 55, you have a application based problem where they have given you some model of length and surface area depending on each other. So just find the derivative of the L function with respect to a, and in the end put a equals to 12. In question number 56, they have given you some s of a function. Find the derivative of that function with respect to a and then put a equal to 100. In question number 59, they are asking you about the values of x where the function has horizontal tangents. So the slope of the tangent should be equal to 0. You find the derivative of y function and then set that derivative equal to 0. When you solve that at equal to 0 for the values of x, all those values of x will give you horizontal tangents.